Hello student, I am Latif sir. Today I will discuss about ICSE class 10 chemistry. The topic is periodic table and periodic properties and variation in periodic properties. On this topic, this is my second video. Today I will discuss about periodic properties. So what are these periodic properties? The periodic properties are those properties which shows a regular gradation or variation as we move down across a period or down the group are called periodic properties. That is, periodic properties are those properties of element which shows a regular variation or regular gradation, that is increase or decrease as we move across a period, that is from left to right or down the group, that is up to bottom. So these properties are called periodic properties. So in one word, the properties of element which show a regular gradation or variation, that is increase or decrease across a period, that is left to right, from left to right, or down the group, that is from top to bottom. So some example of periodic properties are important periodic properties are: first, atomic size; second, metallic character; third, non-metallic character; fourth, ionization potential; fifth, electron affinity; sixth, electronegativity. Today I will discuss about atomic size, metallic character and non-metallic character. Let's start. What is atomic size or atomic radius? Atomic size or atomic radius is the distance between the center of the nucleus of an atom and its outermost shell. You can see the diagram. The atomic radius or atomic nucleus means atomic size means the distance between the nucleus and the valence shell electron, that is outermost shell electron. So atomic size or atomic radius, it is the distance between the center of the nucleus of an atom and its outermost shell, that is valence shell. Now atomic size depends on two factors. One is number of cell and another is nuclear charge. You can see atomic size depend on two factors. One is number of cell and second nuclear charge. Now let's see how number of cell and nuclear charge uh, affects on the atomic size. So an increase in the number of cell increases the size of the atom. You have to remember, increase in the number of cell increases the size of the atom. This is because the distance between the outermost cell and the nucleus increases. So when number of cell number increases, distance between nucleus and outermost cell increases. That's why atomic size increases. Second factor, nuclear charge. Nuclear charge is the force of attraction between the positive charge of nucleus and the valence shell electron. An increase in the nuclear charge, that is number of proton in the nucleus, that is positive charge in the nucleus. An increase in the positive charge in the nucleus, size decreases. This is because on increasing nuclear charge, the force of attraction between the nucleus and the valence shell electron increases. That's why that's why the force of attraction increases between the nucleus and valence shell electrons, therefore the outermost shell come closer to the nucleus. That's why size decreases. So an increase in the nuclear charge decreases the size of the atom. This is because the electrons are then attracted towards the nucleus with a greater force, thereby bringing the outermost shell closer to nucleus. Now, trend in atomic size, that is, or variation in atomic size down a group or and along a period. So how atomic size varies along a period or group. Let's see, down a group, down a group, that is from top to bottom. If you go from top to bottom, you will see that number of cell increases one by one. Therefore, the distance between the nucleus and outermost cell increases, so atomic size increases. So on moving down along any group, the atomic size increases. This is due to successive addition of new cell down a group. Okay. For example, in case of group 1 element, the elements are one element, that is alkali metals. The elements are hydrogen, lithium, sodium, potassium, rubidium, cesium. From top to bottom, the elements of group 1 elements are hydrogen, lithium, sodium, potassium, rubidium, cesium. Okay, so atomic size order will be same. That is hydrogen less than lithium, less than sodium, less than potassium, less than rubidium, less than cesium. Similarly, in case of group 17 elements, group 17 elements are from top to bottom: fluorine, chlorine, bromine, iodine, astatine. You can see here group 17 element. So now we know that down the group, atomic size increases. So the largest is astatine 80, and for group 17 element, and the smallest is fluorine. Now across a period, that is from left to right, we know that from left to right, nuclear charge increases, therefore atomic size decreases. Atomic size decreases. So from in a period, the size of an atom decreases from left to right. This is because the nuclear charge or atomic number increases from left to right in the same period. Thus, the order of atomic size for second period element. Second period element, which are second period element? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. These are second period element. You can see. So we know that on going left from left to right, atomic size decreases. So among these elements, lithium is the smallest in size, while fluorine, yeah, lithium is the largest in size, and fluorine is smallest in size. In case of group, yeah, period two element. Okay. In case of third period element, and the third period element are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. So, what is the order of atomic size? Sodium is greater than magnesium, greater than aluminum, greater than silicon, greater than phosphorus, greater than sulfur, greater than chlorine. Because we know that along any period from left to right, atomic size decreases. So, in case of third period element, sodium is the smallest, and chlorine is the, yeah, sodium is the largest, or and chlorine is the smallest element. And you have to remember one point: group 18 elements. Group 18 elements have unusual higher size, atomic size, compared to group 17, 16 element. Okay, so you have to just ignore the group 18 because they have unusual higher atomic size. Note, as an exception, the size of inert gases, that is group 18 element, are higher due to maximum electronic repulsion among the electrons present in the outermost shell of group 18 elements, that is noble gas element, or inert gases. Why? The reason is inert gases have completely filled orbital valence shell. That's why there is a maximum electronic repulsion among the electrons present in the valence shell of this element. Therefore, their size is higher compared to group 17, 16 element. Okay. Note, size. You have to remember one point: size of anion always greater than size of neutral atom, and size of neutral atom is always greater than size of cation, because anion form by accepting one electron, and cations are formed by releasing one electron. So after releasing one electron, atomic size will decrease, and after gaining one electron, atomic size will increase. So atomic size of anion must be higher than the size of neutral atom, and size of neutral atom must be higher than size of cation. Therefore, one example is I minus, that is iodide ion, get the size of I minus is greater than size of neutral iodine and greater than size of I plus. Now metallic and non-metallic character. Metallic and non-metallic character. Metals are those element. Metals are those element which have a tendency to lose their valence electron. So how to identify a element is a metal or non-metal? The simple technique is the metal are those elements which have a greater tendency to lose their valence electron, and as they are losing electron, that therefore they will form cation, that is positive ion. You can see here sodium electronic configuration is 281 because atomic number of sodium is 11. So sodium will release one electron to form Na plus, Na to Na plus, because Na plus has electronic configuration 28. In K cell 2 electron, in L cell 8 electron after releasing one electron. And among Na and Na plus is more stable, because in case of Na plus there are 8 electrons in the valence shell, and according to octet rule we know that 8 if there are 8 electrons in the valence shell of an element or ion, then the element or ion will be more stable. That therefore Na, among Na and Na plus is more stable, because Na plus there are 8 electrons in the valence shell. So Na plus easily lose one electron. Here you have to remember atom metallic character depends on two factors: atomic size and nuclear charge. You have to remember metallic character means the tendency of releasing electron or losing electron, valence electron. We know that larger the atomic size, larger the atomic size, greater is the metallic character. This is because larger the atomic size, smaller the force of attraction between the nucleus and valence electron. Therefore, as the force of attraction between the nucleus and valence electron decreases, huh, then the tendency of losing electron will increase. Therefore, larger the atomic size, greater is the metallic character. Now, greater the second point, greater the nuclear charge. Greater the nuclear charge means greater is the force or pull of attraction between the valence and valence electron and the nucleus increases. So, greater the nuclear charge, force of attraction between the nucleus and valence shell increases. Therefore, tendency of losing electron decreases because force increases, force of attraction. Therefore, metallic character decreases. So, larger the atomic size, greater is the metallic character. Greater is the nuclear charge, lesser is the metallic character. Now, trend in metallic character. Trend in metallic character or variation in metallic character, down a group and across a period. We know down a group atomic size increases due to addition of successive cell. Down a group atomic size increases, therefore force of attraction between nucleus and valence shell decreases. Therefore tendency to release the electron or lose tendency of losing electron decreases, increases. That is, the electrons is easily uh, it is easy to take out one electron from the valence shell due to increasing size. So on moving down a group, the size of a atom increases. Therefore the tendency to lose electron increases and metallic character increases. In group 1 elements are, except hydrogen, the metals are lithium, sodium, potassium, rubidium, cesium from top to bottom. So we know that down a group atomic size increases, metallic character also increases. So among these elements, cesium has most metallic character and lithium has least metallic character. Now across a period, that is from left to right along any period, we know atomic size decreases due to increase in nuclear charge. As the size decreases, the force of attraction between the nucleus and outermost shell increases. Therefore, it is not easy to release the valence shell electron because force of attraction increases from left to right along any particular period. So the metallic nature decreases across a period. Metallic nature decreases across a period, moving from left to right. Example, in the second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen. There's a second period element you can see. So we know that from left to right along any period, size decreases, metallic character decreases. So lithium and beryllium has the most metallic character in this period, and boron has metalloid. Boron is a metalloid, that is boron has both property of metal and non-metal, and carbon, nitrogen, oxygen, fluorine are non-metal, that is from left to right metallic character decreases and non-metallic character increases. Now non-metallic character, just opposite of metallic character. The metallic character is tendency to lose electron and non-metallic character is tendency to gain electron. Hmm, tendency to gain electron in order to attain octet in their outermost orbit. So non-metallic character, those elements which have a tendency to gain electrons in order to attain octet in their outermost orbit or are considered as non-metals. Non-metal usually have 5, 6, 7 electrons in their outermost orbit. While you have to remember metals have 1, 2, or 3 electrons in their valence shell, while non-metals usually have 5, 6, or 7 electron. Non-metals usually have 5, 6, or 7 electrons in their outermost orbit. Therefore, they can gain 3, 2, or 1 electron respectively in order to attain octet, and as they are accepting electron, therefore they form anion. So for example, chlorine has atomic number 17, then electronic configuration is 287. For chlorine, it is not easy to release 7 electron to attain the octet in the valence shell, but it is easy for chlorine to accept one more electron to becoming 8 electrons in the valence shell, that is in order to attain octet in the valence shell. Therefore chlorine easily accept or gain one electron to form Cl minus ion, and among Cl and Cl minus ion, Cl minus is more stable because Cl minus has 8 electrons in their valence shell, while Cl chlorine atom has 7 electron in its valence shell. Now similarly for oxygen, electronic configuration 2 6 because atomic number is 8, it will gain 2 electron to form O2 minus. If one electron gain, 1 minus, for example Cl minus, Cl take 1 electron to form Cl minus. Oxygen take oxygen accept 2 electron to form O2 minus. Okay. Now non-metallic character also depends on two factor: atomic size and nuclear charge. Non-metallic character also depends on two factor: nuclear charge and atomic size. And we know non-metallic character just metallic character. Now smaller the atomic size, more is the non-metallic character. While smaller the atomic size, the metallic character is low, and smaller the atomic size, more is the non-metallic character. Just opposite, metallic character and non-metallic character just opposite. Smaller the atomic size, more is the non-metallic character and smaller the atomic size, more is less is the metallic character. Similarly, greater the nuclear charge, more is the non-metallic character, because greater the nuclear charge there is a greater tendency to accept or gain electron. Now trend in non-metallic character. Down a groove, that is top to bottom, non-metallic character, non-metallic character decreases because metallic character increases down the group. Similarly, for example, group 14 element carbon, silicon, germanium, tin and lead C, Si, Ge, Sn, Pb. So carbon is non-metal, silicon and germanium is metalloid, and tin and Pb, that is lead, are metals. So down a group, non-metallic character decreases and metallic character increases. And across the period, from left to right, on moving from left to right, that is across a period, non-metallic character increases because metallic character decreases across the period. For example, in third period element, sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Here you can see sodium and magnesium metals, uh, and chlorine is a non-metal. So from sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine, non-metallic character increases but metallic character decreases. And in the next day, I will discuss about electron affinity, electron enthalpy, ionization enthalpy, and electronegativity.